Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're talking about piecewise functions. Piecewise functions is basically taking pieces of different functions and putting them together to form one graph. And it looks way harder than it really is. I know when you see this, that looks a little scary. It's like, what is going on there? That's a lot of numbers. A lot of symbols, right, in one, but I promise if we just take it one step at a time, it's not too bad. The first thing they're typically going to ask you to do is to graph a given piecewise function, and this is our piecewise function, okay? They're going to ask us to graph this, and then we're going to get over here to some evaluating questions to be able to evaluate some different values and to determine domain and range. We're not there yet, so we're just going to kind of save that to the end. For this piecewise function, the way we read this is f of x equals, and it's all of these things working together, okay, to create one picture. So f of x equals 2. That's our first equation, okay? And remember, f of x is just a fancy way to say y when we're talking about a function. So this is really y equals 2, which hopefully some of you guys are thinking, isn't that a horizontal line? Yes, okay. When y equals 2, that's a horizontal line, but we'll get there. If you didn't catch on to that, that is okay. Okay, we'll figure that out. So we've got y equals 2 if x is less than or equal to -1. Now I'll tell you, I have some students that get all the way to high school and they still do not know they're less than or they're greater than. Just as a quick refresher, if that's something you struggle with, it's an easy fix, okay? You look at the symbol and you say, does it look like an L? Okay, so I'm going to hold an L up like that. Does that symbol look like it faces the same direction? Generally, does it look like an L? If the answer is yes, it's a less than. Okay, if the answer is no, it's a greater than. So looking ahead, just skipping just for a second down here, do you see that that one does not look like an L? It's facing the wrong way. That's a greater than. Back to piecewise functions. We got y equals 2 if x is less than or equal to -1. So that means we only are talking about the numbers less than -1 or equal to -1. So we got -1, -2, -3, -4. I could keep going on forever, okay? Any number less than -1, we will use that first function, okay? Now let's move on to the second one. So the second one says f of x or y equals -x plus 4. If x falls between, that's kind of how we read that. If x falls between -1 and is less than or equal to 4. So x has to fall between these numbers, and it could also equal 4. Okay, it could not equal -1 because that doesn't have that little or equal to line with it. Okay, I know that can be kind of complicated and overwhelming to look at, but just always think when you see that double less than, what it's saying is x falls between those two numbers. So what are the numbers that fall between -1 and 4? Well, we've got 0, 1, 2, 3, and 4, right? So if it's any of those numbers, we'd take the second piece. And finally, we got that third piece. So y equals 3x minus 9 if x is greater than 4. So anything above 4, which would be 5, 6, 7, 8, 9, 10, whatever it may be. If I've lost you, don't worry. I'm going to pick you back up right here, okay? I've kind of created some little T-charts to help us. Now, on your tests or your quizzes or even your homework, they're probably not going to give you these, okay? You're going to want to create them yourself, but for the sake of time and organization, I just went ahead and wrote them out. And notice I sketched one T-chart for each equation. So that's for the first one, this is for that second line, and this is for that third line. We're going to take each line individually, okay? So to help me do that, I'm going to bring out my graphing calculator. And for the first part of the equation, and I've got it written up here, so I'm not covering it up. So I want to graph that equation. So remember, I go to my y equals to do my graphs, and that's y equals 2. And I want to look at my table. I want to figure out what are my table of values. So I'm going to go to my graph, and there's tons of numbers here, right? Like, where do you start? Well, that's when the if statements come in. So notice it said y equals 2 if x is less than or equal to -1. Okay, so that gives me a starting place. So I want x to be less than or equal to -1. Okay, so that tells me where to start my t-chart. I'm going to start it at -1. And I also want the numbers less than -1. There's no exact right amount of how many to include other than, maybe just choosing the stuff that you can graph easily, but the numbers less than -1 would be -2, right? -3, -4, and so on, right? It doesn't end, it would just keep going. So I like to show that in my t-chart with an arrow to show that we want the numbers up to -4 and beyond, right? And keep going down with the numbers. And then we want to figure out, okay, well, what's my corresponding y value to these? And if you notice, on each one, right, what's my y value? It stays 2, okay? So every single time, it's 2. Which should also be another red flag that probably looking at a horizontal line. But maybe we still haven't figured that out yet, and that's okay. So it would be 2, and notice that 2 keeps continuing, right? So the 2 also goes down and beyond. We show arrows because those are going to end up being, it's going to end up being an arrow on our graph as well. Now, one quick thing we need to note before we move on to our next t-chart, very important, is that notice this said x was less than or equal to, okay? That means it could be -1, right? That is a solid point. Remember where we talked about that included points have an or equal to line and open unincluded points do not, kind of like that one, doesn't have an or equal to line. So that means that right here at -1, 2, we have a solid point, and I like to show that with just a dot on the side to show that that is a solid point at -1, 2. So let's go ahead and let's graph this line. Before we even move on, let's go ahead and graph just this part, okay? So let's see, we're going to plot our first point at -1, 2, and it's going to be a solid point. So -1, 2, a solid point. And then we're going to graph our remaining points. And when we're talking about stuff in the middle, right, so from here to, on down, these are all going to be solid points, okay? It's that starting one that we really want to make sure we pay close attention to. So I would graph my next point at -2, +2. And my next one at -3, +2. And that one at 4, -4, +2. And then remember we said and so on, right? Like and with an arrow, okay? And at this point, hopefully you notice we've got a horizontal line. Now I know the temptation is for a student to hold this up and they want to just do a big line all the way across, which would be incorrect, because remember, we're not just graphing lines, we're graphing pieces of lines. We're graphing sections of lines. And how do we know the section? X has to be less than or equal to -1. So it can only be from here on. X can't be over here. That's the restriction that they gave us. So we just got to be careful that we don't get ahead of ourselves and start just graphing lines. All right, let's move on to our second part, our second t-chart. So remember, this one is our negative x plus 4. And then they gave us some restrictions on this one. They said if x falls between negative 1 and positive 4. So I'm only going to put on my t-chart the numbers that fall between negative 1 and positive 4. So I'm going to do negative 1, 0, 1, 2, 3, and 4. So to figure out what values go with those, I'm going to come to my graphing calculator and I'm going to type that in. Negative x plus 4. We're going to do second graph to go to my table. And remember, I wanted to start at negative 1. So let me scroll down. Right there, negative 1. And its partner is 5. Its y value when x is negative 1, y is 5. I'm going to do the same thing for each of these values. So when x is 0, y is 4. When x is 1, y is 3. When x is 2, y is 2. When x is 3, y is 1. And when x is 4, y is 0. Now before I just start graphing, we want to make sure we pay attention to those open or closed circles. So notice over here with the negative 1, we did not have an or equal to, which means that is an open circle. And I like to show that as an open circle right there. Now, some people may like to just do a little open circle on the side, and that's fine too. I just like to make it real obvious that that whole thing, that is an open circle at that point. And what about the 4? What about the other end? So that end had an or equal to, which means that 4, 0, that's a solid point. Okay, so we don't have an arrow on this particular one. It's a very clear segment from here to here. So let's go ahead and graph that. Okay. All right, so notice I didn't add any arrows on here. There are no arrows, okay? It's just a section. It's a piece of the function. Now I do have a third line, so I've got to take care of that line real quick. So 3x minus 9. Remember they said if x is greater than 4. So that means my starting place would obviously be x being 4, but then I also want numbers greater than that. So I'm going to pick the next few numbers up. I'm going to pick 5 and 6. And you want to have at least 3 or 4 points total. So I'm okay with 3 on this one. So let's grab out our graphing calculator to speed up some time and graph this. So 3x minus 9. We want to hit second graph to go to our table. And remember, I want 4. I want numbers 4, 5, and 6. So there they are. And my corresponding y values would be 3, 6, and 9. And then remember, it's 4 and above. So do we stop at 6, 9? No, we would keep going, right? And that just reminds me that we're going to have an arrow when we get to that area of the section. And let's refresh our memory. Is there a or equal to underneath that inequality? No. So is that 4, 3 an included point? No. That is an open circle. So we show that with an open circle. Now let's go ahead and graph this final piece of the piecewise function. Okay. Notice that I wasn't even able to graph the point 6, 9 because at 6 I would be off the graph. That would be somewhere up here, and that's okay, right? I know it's a line, it's a linear equation going up, so I've got that arrow. Whether it's at 5, 6 or at 6, 9, it doesn't matter. This is our graphed piecewise function. We're taking different pieces of functions to create one picture. So we're finally ready to evaluate these, and there's really two ways to go about it. You could either evaluate them using the equations, or we could evaluate them using the picture. And what we're going to do in this video is we're going to do both. So we're going to first evaluate it using the equation, and then we're going to double check it on the graph. Okay, so when they say f of 3, that they want you to evaluate it, what they mean is that when this is normally f of x, right? And what have they put in the place of x? Well, they've put a 3. So since they put a 3, what this really means is that x equals 3. So when it comes to our equations, we want to ask ourselves, which piece would x equal 3 fall into? Would that fall into the piece of x is less than or equal to -1? Well, no. Would 3 fall between -1 and 4? Yes. So since 3 falls in between these two values, that means this second equation, that's going to be what we want to use to solve. This is -x plus 4, so I'm just going to rewrite that. And then instead of x, what are we subbing in? 3. So remember, it's -3 plus 4. And -3 plus 4 is a +1. So the answer for f of 3 is +1 for this given function. And we can double check it on the graph, right? So where is x 3? And this is our x-axis, and x is 3 right there, right? So we would want to look at what's the picture doing? Where's the picture at when x falls at 3? And we see it falls at +1. And isn't that what we got? So obviously it's way faster to just look at the graph, but you want to know how to do both. For f of -4, which category would that fall into? And hopefully you're looking right there. X is less than or equal to -1. Is -4 less than or equal to -1? Yes. So that's the equation that we're going to use. Now notice, that equation it doesn't really look like an equation, right? It's just y equals 2. So what do I do with that? Well, that's just the answer. It's 2. So if x is any number less than -1, y is 2. And isn't that what we found on the t-chart, right? No matter what x was, y was 2. And we can prove it again on the graph, right? If x is -4, what is y? 2. Okay, so that one's actually kind of an easy one. And for f of 5, remember, what's in the place of x? 5. So we would want to figure out which equation would that fall into. And hopefully you're looking here, right? Isn't 5 greater than 4? That's the only true statement for 5. So we would want to use this equation right here, 3x minus 9. But remember, what are we putting in the place of x? 5. So 3 times 5 is 15, and 15 minus 9 is 6. And we can prove that again by looking at the graph. So when x is 5, where's y? 6. Okay. And then when we want to do the domain and range, just to kind of top it off, to have a full comprehensive look at this graph, for domain, remember we read left to right, right? So when I come from the left, the first thing I touch is an arrow, which is -infinity. And when I come from the right, the first thing I touch is +infinity. If you need a review on that, definitely check out my video on domain and range interval notation. And some people I know are thinking, we've got breaks in this graph, right? Don't we have a hole there and a hole there? Like, how can we possibly say the domain is -infinity to +infinity? Well, here's the thing. So even though there are breaks, what looks like holes in the graph right there and right there, look at what's happening. When there's a hole there, there's a filled in point there. So it's kind of like this one is empty, but this covers for it. Okay, and the same thing here. You would just want to make sure, yeah, that one's empty, so it could potentially be a hole in the graph, but look at that one. That's a filled hole, which covers the place of it for our domain. And then for the range, we want to go through that same process, but this time we read from bottom up. The first thing I touch is actually y equals 0. Okay, don't say 4. That's where x is. Y is at 0. And it's a solid point at 0, so we mark that with a bracket. And when we read bottom down, the first thing we hit is an arrow, so that is a positive infinity. And again, the same rules apply with those holes. So even though it looks like a hole here, look, it's filled in right there. And this one looks like a hole here, but look, it's filled in. And some people may say, oh, but there's not a big dot there, right? It's okay. That's a solid line. That solid line has many points in it. Okay, not just the one I drew, but tons and tons of points within that line that are filled in points. So it's covered right there. All right, let's look at another example. So in this one, this time our piecewise function only has 2 pieces. Okay, sometimes it'll have 2, 3, 4. You know, we don't typically assign more than 4 for just a regular high school math class, but that doesn't mean you couldn't see it, especially as a bonus. In this case, we only have 2, which is nice. So we've got f of x, or just y, equals 2x plus 1 if x is greater than or equal to 1. And we've got y equals x squared plus 3. This time we've got a quadratic going on. If x is less than 1. So we've got some restrictions set for us here. So remember, we want to start with creating our t-chart. If you don't have one created for you, you definitely want to take the time to do that. And we'll plot in our first equation, so 2x plus 1. We just focus on one piece at a time. Second graph. Remember that this is x's greater than or equal to 1. So I definitely want to start at 1, and then I want numbers greater than 1. So let's go with 2, right, 3, and 4. So let's figure out what values would go with those. We've got 1, 3, 2 goes with 5, 3 goes with 7, and 4 goes with 9. And would it stop there? No, because it's any number greater than 1. So we would definitely want to have our arrows to show that we would have an arrow at that point on our graph. And let's make sure we understand if we've got an open or closed circle. At this point, I see we've got an or equal to, which means a closed circle at this 1, 3, a closed point, an included point. Let's go ahead and graph that. Okay, so we've got our first piece of our piecewise function graphed. We want to go ahead and graph the second piece as well. So to speed up, I'm going to bring out my graphing calculator. So this is an x squared plus 3. I'm going to go to my table, make sure I double check my parameters. So it's x is less than 1. So that means we start at 1, and then it's our numbers less than that. So we've got 0. Right, -1, and let's just go one more. Let's do -2. And does it stop at -2? No, it keeps going. So we want to show that with an arrow. And let's fill in what our values, our matching values will be. So we've got a 1, 4. 1 goes with 4. 0 goes with 3. -1 with 4. and -2 with 7. And again, that continues on, so we want to have an arrow in that part of the graph. And so then does it include 1? No, because we do not have a line there. So that means we've got an open circle here at 1, 4. So let's go ahead and plot that part of the piecewise function. Okay, so notice what we've got here. This one's definitely a little strange looking, and it's because this is a quadratic, and normally it would be a full U shape, but we only want a part of it. So we've just got this kind of J part of the U, okay? Little backwards J. And that's okay. That's what happens when we have a quadratic as part of our piecewise function. So at this point, we're ready to go ahead and evaluate. So when we want to evaluate f of -2, that would fall into our x is less than 1. We'd want to use that second equation. We're going to use the x squared plus 3. And instead of x squared, we're going to put in -2 squared plus 3. I cannot emphasize enough how important those parentheses are. If you do not have them, you will get the wrong answer, okay? So -2 squared is 4, and then add 3 to it, we get 7. We can double check, just verify that on the graph. When x is -2, didn't we say we fall at 7? Yep. All right, what about when x is 6? So again, that would fall, this time that would fall into our x is greater than or equal to 1. So we're going to use that first equation. So 2x plus 1. But it's not x, we're going to say it's 6. 2 times 6 is 12, plus 1 is 13. So what's interesting is you'll notice we can't check that one on the graph. Because if I look where x is 6, oh no, like I know my graph keeps going up, but where do they meet? I have no idea. So that's why it's important to know how to do the equation and not just looking at the picture. And then for f of 1, and you may be nervous because you see a 1 there and a 1 there, but which one is equal to 1? Well, that would only be the top because of that or equal to line. So we would write this as our 2x plus 1 equation, but instead of x, we're going to put in a 1. 2 times 1 is 2, plus 1 is 3. And when we want to find our domain and range, from left, first thing we touch is an arrow, so that is a -infinity, and then from the right, arrow, positive infinity. We just want to double check and make sure that every part within that is covered, and even though we have a hole right there, it's covered right there. We're good, okay? And then for our range, lowest place I touch is 3. It's okay that it's at 2 different places, still at a bracket 3. And from the top down, we got a infinity. All right, this will be the last example we walk through together. Sometimes you are going to be asked to write a piecewise function. So notice the difference here. They've given you a graphed picture of a piecewise function, and you have to come up with what would the equations be. And that can definitely be tricky. But again, if you just take it one piece at a time, it's not too bad. So looking at this, I would start with just one of these pieces. Obviously, there's only 2 of them, right? So I'm only going to have 2 equations here. Looking at this first one on the left, I notice it's a linear equation. Okay, it's a straight line, so that's a big hint. And what are the 2 things I need to know for a linear equation? So remember, linear equations are y equals mx plus b, right? And to figure this out, I would need to know the slope, m, and I would need to know the y-intercept, b. So looking at that, I do not see the y-intercept. I know it would happen somewhere up here, but I don't know what it is, okay, because my piece stops right there. So there's a couple different ways I can use the slope and kind of work backwards, right? Or if you've got a ruler or a straight edge and you've got a really clear graph picture, you can look to see where would it cross the y-axis, and you see right there it would cross at +5. It's kind of a shortcut. Obviously we could take the slope and work backwards to find the y-intercept, and that's probably the safer option if we don't have a really clear graph, but here we definitely have a clear graph and I can see that y-intercept would be at +5. And then as far as the slope, all I have to do is count rise over run. Remember, slope is rise. So if I just picked a point, right, how many do I rise to get to the next point? 1. And how many do I run to get to the next point? 1. Okay, and it was up 1, right 1. So +1 over 1 or just 1. Okay, so I know that my first equation is y equals m, but we said the m was 1, so we don't have to write 1. We can just write x. 1 is understood, plus 5. We said the y-intercept was a +5. All right, now where does this piece occur though? Like, notice we've got an arrow here, so it's going to be, we're moving in the negative direction of the x values. So where do the x values start? Well, they start at -2, and then it's everything below -2, never above, right? And is the -2 included? No, because we've got that open circle there. So that tells me that x, so we'll add our little if statement, so x plus 5, if x is less than -2. It's not going to be less than or equal to, again, because we got an open circle there. So there's my first line. Now my second line, I notice, is a horizontal line, so that might be a little bit easier. I think they're a little easier. Remember, horizontal lines are just in the form y equals a number, whatever the y-intercept is. In this case, my y-intercept is -2. So it's just going to be y equals -2. Right? There is a slope of 0. If you really want to break it down like this, if that's helpful to you, the slope of a horizontal line is always 0. And the y-intercept is -2. We see that right there. Not always, but just for this one, it's -2. So you could write this as y equals 0x minus 2, right? But we would never see it written like that. The 0x would always just cancel to 0. So we write that as y equals -2. And we want to add our if statement, our restriction, that where does x fall for that rule? Well, x starts at -2. It's an included point, it's solid, and it's any x value above that. So we would want to say if x is greater than or equal to -2. Okay, here's one for you guys to try on your own. So if you've got graph paper available to you, go ahead and try to graph this piecewise function. See if you can create it. And then I want you to evaluate each of these. Now you could either use them just with the equation, or you could use them on the graph, completely up to you. I will post the answer to number 1 and number 2 in the video description below. This has been Miss Math Tutorials.